In this section, we are solving equations involving exponential or logarithmic functions. So I thought it would be best just to do a lot of examples, throw a variety of types of equations at you and see what we do. All right, the first one I have is this equation. We want to find the value of x that makes this true. I'm going to begin by dividing both sides by 3. If I divide both sides by 3, I'm going to have 5 to the 6x is 25. And now I notice something. I notice that 5 and 25 can be written with the same base. 5 to the 6x and 5 squared. If the bases are the same, their exponents have to be equal. It just makes sense. So 6x must be 2 and x must be 1/3. Let's come over here. I'm going to approach this as in I'm going to isolate the 2 to the 3x minus 7. So I'm going to get rid of everything else that's with the 2 to the 3x minus 7. I'm going to begin by subtracting 20 on both sides. And now I'm going to divide both sides by 5. 16. And now I'm kind of at this step where I notice that 2 and 16 are both powers of 2. So I can write this as 2 to the 3x minus 7, and 16 I can write as 2 to the 4th, and now their powers must be equal. So 3x minus 7 must be 4, 3x must be 11, so x must be 11 over 3. Okay, this one looks very messy, very complicated, but I do, inside, I notice powers of 3 on the inside. So I'm going to approach it like that. I'm going to approach it where hopefully I can get it to be 3 to a power is 3 to a power. So I'm going to write this as 3 to the 2x over 7. I'm going to write this. I might take this in pieces. I might start by saying, okay, 27 is 3 cubed. And 3 cubed times 3 squared is 3 to the 5, right? And then a square root can be written as a 1/2 power. Copying that down. So now I have 3 to the 2x over 7 is equal to 3 to the, and when we have a power to a power, we multiply those powers. And I have the same bases, so I can set the two powers equal and finish solving for x. I'm going to multiply both sides by 7 over 2, and I'll get 35 over 4. Here's another one where I'm going to get the same bases. So the base is e. E is just a number. So e to the 3x plus 1 is e to the 5 over 4. So 3x plus 1 must be 5 over 4. I'm going to multiply both sides. I could do a couple of different things here. I'm going to multiply both sides by 4. If I multiply both sides by 4, I get 12x plus 4 is 5. So 12x is 1, and x is 1 over 12. Could have approached that a couple of different ways. Number 5. Okay, set up a little bit differently. I'm going to rewrite this here. 2 to the x over 2 to the x minus 4 is equal to 5. I'm going to begin by multiplying both sides by the 2x minus 4. If I multiply both sides by the 2 to the x minus 4, I'll have 5 times 2 to the x minus 5 times 4, like that. And now I'm going to subtract, I'm going to combine these 2 to the x terms. So 2 to the x, I'm bringing it to the other side. So I'm subtracting, I'm going to move this negative 20, I'm going to move it to the left. it'll be a positive 20. This 2 to the x, I'm moving to the right. And I'm subtracting 1 2 to the x from 5 2 to the x, and that leaves me 4 times 2 to the x. Just subtracting like terms. Now I'm going to divide both sides by 4, and I get 5 is equal to 2 to the x. Okay, we have 2 to the x is equal to 5. This one, unlike the previous 4 examples, we cannot write 5 as a power of, with a base of 2. We cannot write 5 as a base of 2 number. So what I'm going to do on both sides, I'm going to do something on both sides. I'm going to take log, since I'm trying to get to the x, I'm going to take log base 2 of both sides. If I do that, log base 2 of 2 to the x is equal to log base 2 of 5. What that allows me to do here is move this exponent to the front, and now it's x, and then I'm left with log base 2 of 2, but that is just 1. So x is equal to log base 2 of 5. Because this here is just a 1. So when you're left with something like this, take a log of both sides with that base. Log base, whatever that is, of both sides. Let's try another one. We have 3e to the 4x minus 1 is equal to 12. I'm going to begin by dividing both sides by that 3. I'll have e to the 4x minus 1 is equal to 4. There's no way to get both sides with a base of e, so I'm going to natural log both sides. I'm taking the natural log of both sides. Okay, here I'm left with just the exponent, because in my mind I'm pulling this to the front where it's the coefficient, and then I'm left with that coefficient times ln of e, and ln of e is 1. And this is equal to ln of 4. And now I finished doing a little algebra to solve for x. I'm going to add 1 to both sides, and then divide by 4. Same thing as multiplying by a fourth. Since I'm out of room down here, I'm just going to write it like that. Okay, let's take a look at this one. Well, I have 9e to the x is 36 over e to the x. I'm going to multiply both sides by e to the x. Multiplying both sides by e to the x. So I have 9e to the, what do you do when you have the same bases? You add the powers. X plus x is 2x. So e to the 2x is 4. And now I'm going to ln both sides. I'm lning both sides. So I get 2x is equal to ln of 4. So x is ln of 4 divided by 2. Or you could write that as 1/2 ln of 4. Or you could write that as ln of 4 to the 1/2 power. What is 4 to the 1/2 power? 2. How do you think that they would write it as a multiple choice answer? Which is the simplest way to write this? This would be the MCQ answer. Okay? Let's try this one. We have 1 over e to the 4x is equal to e over e to the x. Oh, what a mess. I do notice that this is a power of 1 here. I can think of a few different ways to do this. I might like cross multiply here. I'll have e to the x is equal to e to the 1 plus 4x. Add your powers. So Now we have same bases, and I set the exponents equal to each other and finish solving for x. 3x is negative 1, so x is negative 1/3. Okay? Let's take a look at this one. Find the value of x which satisfies this equation. Well, I see a fraction that is equal to 0. And if I see a fraction that's equal to 0, I know that the numerator must be 0. So 5e to the x minus 12 must be 0. That bothers students sometimes. They say, wait, what happened to the 7e to the x? And what I say to that is, if you have a fraction that's equal to 0, the numerator must be 0, period. It doesn't matter what the denominator is, unless my answer makes the denominator 0 as well. So I will check that after I'm done. Okay, so I get 5e to the x is 12, and then e to the x is 12 over 5. And now I'm going to ln both sides. Ln both sides to get the x by itself. Now x is equal to ln of 12 over 5. And that does not make the denominator 0, so I know that that is my answer. Okay, what if we have an inequality? What if we're finding the values of x which satisfy this inequality? Well, I like having 0 on, for an inequality, we must have 0 on one side. I like having that 0 on that side. I'm going to factor out what's in common. What is in common here? I might factor out a negative 5e to the x. If I take out a negative 5e to the x, from the first piece I have an x left. From the second piece I have a negative 3 left. Multiply it back out and make sure you get back what you started with. And they tell me that this is going to be less than 0. Well, e to the x by itself can never be 0. Remember the graph of e to the x? Graph of e to the x does that. It is never 0, and it's always above the x-axis. So never 0, always positive. Never 0, always positive. X minus 3, though, can be 0. So x minus 3 is 0 when x is 3. What am I going to do with that? The same thing that we did with rational inequalities. I'm going to create a number line, a sign chart. So I'm going to put x is equal to 3 on the sign chart. And I'm looking for which side is positive, which is negative. If I put a number on the right of 3 in for x, any number bigger than 3 in for x, any number bigger than 3 is going to make this positive. This is always positive, but negative 5 is always negative. So this whole thing over here is going to be negative. If I put a number in on this side of 3, I will get a positive. And I know I will because this 3 came from an odd-powered factor, just like we did with rationals. So where do we want this? Where is it less than 0? Well, it's not less than 0 right at 3. It is less than 0 when x is bigger than 3. So my answer will be 3 to infinity, that interval. Another way to write that interval is x is greater than 3. Okay? Now we're going to do some equations that involve logs. Okay, I have log base 2 of x is negative 4. Log base 2 of x. Well, I'm going to apply what I know is true of logs, and that is that they are inverses of exponentials. When I see log base 2 of x, I take 2 to both sides. 2 to both sides. That way, I get just the x over here because these 2 to the log base 2 of an argument, since they're inverses, we get back the argument every time. And then I just have 2 to the negative 4 on the other side. And 2 to the negative 4 is 1 over 2 to the 4, which is 1 over 16. X is 1 over 16. My x is in the argument of the log, so I'm going to take 5 to both sides. 5 because that's the base of the log. And that's how I get to the argument. 5 cubed is 125. And now all I need to do is square root both sides. X is plus and minus square root of 125. I could take a 5 out of that and make it plus and minus 5 square root of 3 if I wanted to, and that would work as well. Okay? Alrighty. Number 13 here. I'm going to begin by isolating my natural log here. So natural log of x will be 5. Now what do? We take e to both sides. E to both sides to get to our argument. So x will be e to the 5th. And that's just our answer. Okay, let's take a look at this one. Here I don't have a single log, so my first step is going to be to condense these, make these one single log. So I'll have ln of 1 log, 1 argument. So I'm going to have x plus 4. It's going to be in the numerator of my argument because it went with a positive log. The x minus 1 is going to be in the denominator of my argument because it was with a negative log. And that is equal to 6. Okay, so now this is good. I have my natural log isolated, so I'm going to e to both sides. E to both sides. So I have x plus 4 over x plus 1 is e to the 6. It's a little messy. I'm going to multiply both sides by the denominator. I'm going to multiply both sides by x plus 1. But now it becomes problems that we should already know how to solve. So I'm going to have x plus 4 on the left is e to the 6. That's just a number. It's just a number. I'm thinking of that like a 7 or something. X plus e to the 6. And now I'm going to collect all of my x's on one side. So I think I'm going to subtract this x to the other side and move this e to the 6 to the left. So e to the 6 is just a number, so I put it on the side with my numbers. So 4 minus e to the 6th is e to the 6th x minus x. I'm still trying to get x by itself. I'm going to factor out an x. And I'll have x times e to the 6th minus 1 is 4 minus e to the 6th. Last step, divide both sides by e to the 6th. I'm sorry, divide both sides by e to the 6th minus 1. Like that. That was a messy one. That was really messy. I have a feeling that I didn't expect it to be so messy, but it was. Alrighty, let's take a look at the next one. Okay, so first step is going to be to combine these logs, make it one single log. Okay, this time both the logs are positive, so when I write the argument, I'm going to multiply those two arguments together. So it'll be x times x plus 8, and that will equal 2. Okay, I have my argument isolated, so I'm going to take 3 to both sides. So I have x times x plus 8 is equal to 9. X squared plus 8x minus 9 is 0. Get 0 on one side, and these very nicely factor. And I get x is equal to negative 9 or, positive 1. Negative 9 or positive 1. Now, I have a problem with that one. So in class I would pause and say, what is the problem with those answers? Or at least one of those answers. I see that I got x to be a negative. I got x to be a negative 9. What's that going to do to this right here? It's going to give me a negative argument. Can I have a negative argument? No, I cannot. That is extraneous. I need to remove that from my answer. Is it okay for x to be a 1? Sure. That one's okay. I can definitely let x be a 1 there. So my only answer is x is equal to 1. Okay, what about this one? Let's find all the values of x which satisfy this. Okay, well this one looks fairly nice. I'm wondering why I have this here, but I'm going to take e to both sides. And I have x squared is e to the 42. And now I'm going to square root both sides, and I get x is plus and minus square root of e to the 42, which we could write as plus and minus e to the 42 to the 1/2, which is plus and minus e to the 22. This would be the multiple choice answer. Now I see that I got a negative. I see that I got a negative answer. Is it okay to have a negative this time? Yes, it is, because my argument was being squared. Yes, it's okay to have a negative. So we get 2 answers for x in that problem. Okay. I'm going to begin by subtracting 3 on both sides. And now I'm going to be nice to myself. And I'm going to be nice to myself by taking this power that's on the argument and pulling the power out to be the coefficient on the log. The power on the argument is a 1/2. It's going to be nice for me if I move that 1/2 to be the coefficient on the log. And now I'm going to multiply both sides by 2. Time to e to both sides. I have x plus 1 is e to the 8, so x is e to the 8 minus 1. Okay? A couple more. Whenever I see 2 logs on one side, I combine those to get 1 log. This is going to be ln of the product of these two, correct? The product of those two. Okay. Now, I notice something great. I have an ln on both sides. If you have an ln of something is ln of something, those two somethings must be the same. So I have x times x minus 3 has got to be 10, which means x squared minus 3x minus 10 is 0. And x minus 5 and x plus 2 is 0. So x must be 5 and negative 2. As soon as I see a negative, my haunches are kind of ruffled. So because oftentimes in log equations we get a negative that we have to get rid of. If we put a negative 2 in for either this x or this x, we get a negative argument. That is no bueno. Is 5 okay? Absolutely, 5 is okay. All right, one last example. I see I have an e to the x on the bottom. I'm going to begin by multiplying both sides by e to the x. So I'm going to multiply both sides by e to the x to get rid of the denominator over here. So I have 3 plus e to the x is 2e to the 2x. We add the powers. Same bases multiplied together, add the powers. Now I'm going to subtract e to the x on both sides. Oh, actually, I'm going to get 0 on one side. I'm going to get 0 on one side. So I have 0 is equal to e to the 2x minus e to the x minus 3. Okay. I do that because I have, this is very similar to like x squared minus x minus 3. So I put it in like almost a quadratic-ish form that I will factor just like I do a quadratic. 2e to the x times e to the x. If I multiply those two together, I get 2e to the x. Okay? If I multiply these two together, I need to get a negative 3. And if I put the 3 here and the 1 there, I need to make this 3 negative. All I'm doing is factoring, just like you've done for a long, long time. If I FOIL this back out, I get exactly that. And these two terms multiply together to get 0. So now either this is 0 or this is 0. So I'm going to set both of these equal to 0. 2e to the x minus 3 is 0, or e to the x plus 1 is 0. Over here, this gives me 2e to the x is 3, e to the x is 3 halves, ln both sides, and we get x is ln of 3 halves. Nothing wrong with that. That's one of my answers. Over here, I have e to the x is negative 1. If I tried right now to ln both sides, I would have ln of a negative, and I cannot do that. You can never have an argument that is negative. Is there any value of x that would make e to the x negative? No. Never will happen. So my only answer is natural log of 3 halves. So the best way to get good at solving these kinds of equations is to do it. So you need to go and just do some practice problems.